of we guessed the number, and then we divided it out, and then we could factor what was left because it was just a little quadratic. All right, so we're going to do that again. We're going to try another one just like that. So our goal is going to be to sketch, and we're not doing super accurate stuff, we're just doing general pictures. Let's try this one. Oh gosh, I can't read my own writing. All right, let's try this one. Okay. We need to get this factored. Would everybody agree? You remember enough? I know it's been several days, but you remember that if we're going to graph it, we need to know where the x-intercepts are, right? Where we cross the x-axis, and the x-intercepts come from the factors. So somehow we have to get that thing factored. Now take a look at it. Do you notice anything about it?
Factor out.
You could factor out an x. All right, so that would be a good first step to factoring. We can't take out anything else, but we can take out an x. Now, the presence of an x means we're going to have an x-intercept at the origin, right? So we know one of our intercepts is x equals 0. All right, now, we need to factor the rest of it now, though. And whenever I have that many terms, I think about grouping, right? I mean, that enters my mind. Do you think grouping is going to work with this one? No. No, that combination of numbers just doesn't seem like it's going to work. So, do you remember what we did, Patty? Well, we're going to do some synthetic division, but we have to figure out what we're going to divide by first.
I was thinking by 0 because of the origin, but...
Okay, well you can't divide by 0.
Oh yeah.
Remember your my mathlete t-shirt? Yeah.
Oh
You
yeah.
can't divide by 0. We want to find a number though. If you like to do synthetic division, you can just jump in and do it. What has to happen when you do your synthetic division though? This guy right here has to be a 0. Okay? That has to happen, because you're looking for a factor. Now personally, before I set up all the division, I like to look at my problem, and again, you can do this totally with division. If you want to guess a number, divide it out, and hope you get 0, that will work. There isn't anything wrong with that. I think it takes up too much space, so I don't personally do it that way. Instead, I'll look here and I'll say, okay, I need to find some number that's going to give me a 0 when I plug it in, because that's what x-intercepts are. If I tell you I have an intercept at 2, 0, that means if I put in 2, I get 0. That's what I want. I want a number that when I put it in, I get 0. So I like to try 1. If I try the number 1, I'm putting 1 in for x. This would be 2 plus 3 minus 14 minus 15. Is that going to add up to 0? No. How about negative 1? What would negative 1 do? Well, negative 1, I'm putting in negative 1 right here. So negative 1 would give me negative 2, positive 3, positive 14, and negative 15. That looks hopeful. Doesn't that equal 0? Good news, happy. Now I know I'm going to divide by negative 1, and I'm going to get a 0 down here, because that's a factor. That gives me 0 when I plug it in. So I have 2, 3, negative 14, negative 15. I'm going to drop my 2 straight down. Remember this from the other day? Negative 1 times 2, write the answer here, and add. Negative 1 times negative 1, right? Excuse me, negative 1 times 1, write the answer here, and add. Negative 1 times negative 15, write the answer here, and add. And there's the 0 that you had hoped for.
Could you do it a different way by like moving 15x to the other side and then taking x squared out of the equation?
No. Remember that when we go to solve our equation, we go to factor it, it has to be equal to 0. You can't, it's like, what you're saying is, okay, if I had a problem like this, that means that x minus 3 equals 0 or x plus 1 equals 0, right? We have something called the 0 property or the 0 multiplication property or something. So when you multiply two things and you get 0, one of them has to be 0, okay? Now if you move stuff to the other side, I'll just make up, let's say there was a 7, I move it to the other side in that factor, does that necessarily mean that either that is 7 or that is 7? No, it only works with a 0. So your problem has to be set equal to 0. You can't move anything else to the other side.
Okay.
All right, so where am I? I'm lost here. Let's see. So I have found that another one of my roots is negative 1. Right? So I have a factor of x and I have a factor of x plus 1. So far, so good with everybody? The x is the one I factored out in the beginning, and then I guessed, and I got negative 1. Now, tell me about this. That leftover part of my division, what does that stand for? That becomes what equation? 2x squared plus x minus 15. And what about that? That one can be factored. So what are my other two factors then? That would be 2x and x. 5 and 3 plus and minus. Did I get that right? Which means that I have another 0 at negative 3 and another 0 at 5 halves, 2 1/2. Now our ultimate goal was to sketch it. So you now have it factored. We've plotted our x-intercepts. Everybody keeping up? Now what are we going to do? Connect the dots? So I got to keep something in mind. What degree is this polynomial? That's even. And what do we know about evens? Start up, end up, right? Unless you put a negative in front, which we didn't. So this is going to start up, end up. Now also, are any of these zeros, there's 4 of them, are any of them repeated? Like, are there any that are squared or cubed or anything like that? No. So as I hit them, as I come down, because I start up, so I'm coming down, as I hit them, what am I going to do? I'm going to just pass right through them, straight through. And that is an approximate sketch of this curve. We don't know how far down these things go, and that's okay. That's the sketch of it.
How do you know if it goes through or bounces?
Somebody tell her. How do we know if when we hit a 0, an x-intercept, we just go straight through it like we did here, or if we're going to bounce off at a tangent? Yeah, the factor's squared or not. The factors are squared. They bounce off. All right, let's try one more. This is really a big chunk of this chapter. Lots of skills involved here. A couple of observations that I want to make. One is there anything about this procedure that makes you at all nervous? The guessing. Because how many numbers are there out there for you to guess? A lot of them, right? And potentially could this take a long time? Yeah. So I do want to share, I think you know this already, but you may have forgotten it. I want to share with you the idea of possible rational roots. Oh, I shouldn't have erased my problem. Oh well. Possible rational roots. Now, what that means is, if you are faced with guessing, and when do we guess? When we can't factor by grouping. Okay, that's when we guess. So if you are faced with guessing, right now, there are infinitely many numbers out there that you could guess. So I want to narrow down the pool for you. The possible rational roots, which I call the PRRs, are possible rational roots, are factors of the constant over factors of the leading coefficient. Now, you may have called this P over Q or something last year. Does that sound at all familiar to anybody? Okay, that's what's going on here. So what this does is give me my possible rational roots. So instead of me having infinity to guess from, I have a bucket of numbers to guess from. So for this problem, once we got the x factored out, I erased this, so I'll rewrite it. Once we got the x factored out, this is the problem that we were left with. This is the problem that we had to guess. Now, your PRRs for this problem would be factors of the constant. This is the constant. Actually, we can include the negative. This is the constant, okay? The constant is the term with no x. So what are the factors of negative 15? Plus or minus 1,
Plus or minus 15.
3, 5, and 15? Plus or minus all of those? Those are the factors of 15. Divided by the factors of the leading coefficient. This is the leading coefficient. So what are the factors of 2? 2 and 1, right? Plus or minus? So what are my PRRs? Instead of being able to choose any number in the whole wide world, my possible, and that's what these are the possibilities. My possible rational roots are 1, 3, 5, and 15, and then 1 half, 3 halves, 5 halves, and 15 halves. So all of these numbers over 1 and all of these numbers over 2, that's my pool. Now, some of you are saying, Miss Ford, that's still a lot of numbers. You're right, but not compared to infinity, right? I mean, this is better than infinity. Remember, I tried 1 first? 1's always going to be a PRR, so I tried 1 first, and it didn't work, right? So then I went to -1. That's my personal choice. I went to -1. What if -1 hadn't worked? Would I have gone to 2? No, because 2 is not in my list. So I would have skipped 2, 3, and probably tried 3 and -3. Personally, I don't usually try fractions first because it's just a hassle with the arithmetic. But all of these numbers are possibilities. And notice which ones ultimately worked. -3 worked, -1 worked, and 5 halves worked. The numbers that work are going to come out of this pile. So that helps a little bit, right? Let's try one more. And then we got to take our quiz. Alright, so here we go. Does that look like it's going to factor by grouping? Oh, wait a minute. I put that equals 0 on there. We're sketching this. So I want to find what numbers make it 0. We're sketching this. Does it look like it has grouping possibilities? No. So we're going to guess, right? Let's be smart. What are our PRRs? What will I be looking for this time? Factors of Remember, it's always last over first. Like in the Bible, the least shall be first. So last, first, here we go. Factors of 4, 4, 2, and 1. Over factors of 1. So you're going to try, basically 6 numbers is it. That's it. Plus or minus 4, plus or minus 2, plus or minus 1. So what do you think? I don't think 1's going to work. Do you? Nope, we don't get 0. We don't care what we get. It's not 0. What about 2? 2 would be 8 minus 24 plus 14 plus 4. Is that, nope, that's not 0 either. Shoot it to me. Alright, what about, I guess 4. 64 minus, oh gosh, 96 plus 28 plus 4. I put 4 in. Oh, I think that's equals 0, isn't it?
Yeah.
Okay, so woo, luckily we got one that worked. Right? 4 works. Okay. So what do I do? Now that I finally found one that works, the number 4 works, what do I do with it? I divide it out. So out comes the 4. Now, I'm not talking you through that division. You remember what you need to do, right? You need to drop down the 1, and then 4 times 1 is 4, write it here, add. 4 times negative 2 is negative 8, write it here, add. 4 times negative 1 is negative 4, write it here, add, and there's that 0 that we knew we had to get, right? Okay, so what's next? You have found one of your roots. You have found a root to be, or a 0, or an x-intercept to be at 4. How do we go about finding the other 2? Oops. What do we do now? We found one of them right there. What do we do now? Write the new equation, and my new equation would be what? It comes from right here. X squared minus 2x minus 1. That doesn't factor, does it? So to find the answers, to figure out what makes that 0, we'll do negative b plus or minus the square root of b squared minus 4ac all over 2a. So what is that? 2 plus or minus, is that 8? So 2 root 2. Does that simplify it all?
Yeah.
Yeah, because we can cancel out of all 3. So it's going to be 1 plus or minus root 2. Decimally. Anybody know what 1 plus root 2 is? I think that's about 2.4. So I'm just going to put it on there, about 2.4. And 1 minus root 2 would be negative 0.4. So I've approximated those decimals so I could plot them. I didn't know what they were, so I could plot them. Yeah, this is a cubic function. How do cubic functions behave? Start down, ends up. Nothing squared or anything, so starting down, ending up. There we go. Just connect the dots with a nice smooth curve. Now some of you might be thinking, Mrs. Ford, these numbers weren't in my bucket. Remember when we created our bucket of possibilities? Those numbers aren't there. 4 is there, but these numbers aren't there. Can anybody explain why that is? PRR stand for? Possible rational roots. What kind of roots are these? Irrational. And you're always going to find those through the quadratic formula. You're not going to ever guess that. Right? Yeah. Okie dokie. Alright, let's take a quiz. It's exactly what I told you it would be. Remember we did a practice quiz? So those of you that are like, let's run this quiz. I know we did a practice quiz. So you've overshooting, glad you're here today. We need to assume our quiz positions. Anybody have a birthday bonus? Somebody can sit up here in Betsy's seat. Alright, we can use whatever we want. So Wyatt's gonna ask the bonus. Would everybody listen here?
No, I can't sit in the middle.
You don't have to repeat it. Nice and loud, Wyatt. Pretend you're yelling at your brother. 1 times 1 is the bonus. Here we go. Peyton, put everything away. We don't have much time. Why do you have money out? Are you paying me off? It's gonna take more than $5, sweetheart.
I was gonna try.
All right.
$5.
You don't need a calculator. I promise you can do this without a calculator.
Can we use a calculator?